And a lot of people who try out merge replication end up pulling their hair out quite a bit. It's one of those things that it's a little bit different, it's a little bit hard to use, but once you get it working, wow, it's so cool. What merge replication does is it's similar to transaction replication in that it takes an initial snapshot and it sends the data out to a number of locations. But with merge replication, you're able to have the data flowing bidirectional out from a central location out to a store and back to that central location again. Now take the convenience store example that we used, and let's say you're tracking actual product inventory and sales and how many you have in stock at each location. Well, merge replication would be a great use for that, because if one store updates and says, I sold this bottle of soda, for instance, merge replication can sync that back to the central server that's the publisher, and then out to all of the other stores, so that if you ever get in a position where you're looking for a specific product and somebody says, well, we're out of stock with it here, but we can see it over in store 7, go to that store and you can pick it up there, or we can order it for you. That's a good example of how merge replication could be really, really useful. Merge replication takes a little bit more configuration and setup to make it work, and it's a little bit trickier than the others. With SQL Server snapshot replication, I mentioned that all it does is it takes an initial copy of that data and moves it. You don't have to change your table structures in order for that to work. With transactional replication, it does that initial snapshot and then it synchronizes using the transaction log to catch those changes or to catch those things over time. And it does that also without modifying the basic tables that you're using. But with merge replication, it's a little bit different. Merge replication has to modify the tables in some way. First off, for merge replication to work, it has to have a unique identifier that's used to identify each row. So that if 4 different sites are all changing the same row in the database and they're getting synchronized back to the publisher, that unique ID is used in order to do that data sync. So sometimes if you have a unique identifier already in the table, you can use that. But oftentimes with merge replication, it ends up putting on what they call a row GUID, or a unique identifier to identify each row. Merge replication it's a way that the data can be changed in many different locations and then synchronized all back to some central location and sorted out as it gets merged back. Now, that process of bringing it back to that central location can cause conflicts. We haven't used the term conflicts or talked about conflicts with snapshot replication or transactional replication because there are none. The data is changing in one place and it's being published to many subscribers. With merge replication, the data is being changed at many subscribers and then being synchronized and brought back to the distributor and the publisher and then synchronized out to all the other subscribers. So you run into the concept of conflicts. Now, there are default conflict resolvers that you can set up where, based off of specific rules, it will determine which row will be chosen if 2 people change the same row at 2 different locations, for instance, in a table. There's also a point where occasionally with merge replication you get conflicts that can't be resolved by the basic rules that are there, and you have to go into the resolve conflicts feature and find those conflicts, review them manually, and decide as you go through the list which one after which one are you going to accept on each of the different conflicts. That's something that oftentimes I end up writing a script for because I don't like to do that on an hourly basis. But even if you're scripting it, there can be some things that you need to occasionally review and figure out which row is the right winner on that merge conflict. With that, with merge replication, like with transactional replication, you control the time interval of how often it's going to synchronize its data. If you have a server and you tell it to synchronize the data every 1 minute, what it's going to do is every single minute it's going to go and connect to that from the publisher out to the subscriber and say, is there anything that's changed, or anything new you need, and it's going to send any new rows out, any changed rows out, and bring back any changes from the subscriber. Let's say then that's a convenience store, and that convenience store loses their internet connection for an hour. They're still fine to work offline for an hour or two, or even a day sometimes. And then what happens when they come back online, it tries to sync up all of those changes or all of those rows that had been changed at that location, sync it back to the central location. Now, one of the keys here is to reducing the conflicts is reducing the time frame of how often that data is going to be synced. In the example of being offline for 6 hours or 8 hours or a day, yeah, maybe you don't have a lot of control over that if you lose your internet connection. That's okay. It'll do its best to sync up when you're done. But on a regular basis, if you had the choice of saying synchronize these changes every 1 minute or synchronize them every 20 minutes, if you were synchronizing those changes every 1 minute, you're sending back and forth lots and lots of small changes rather than big batches, big sets of changes. And the sooner that a change can get pushed back to that central publisher and then pushed out to all the other subscribers, the less likely you are going to have a conflict. There's been systems I've worked on where we were running into all kinds of conflicts because the data was synchronizing every 10 minutes. And that gave enough time for a person at one location to change the data when a person at the other location changed it and then caused it to conflict. What we did is we changed that from every 10 minutes down to every 1 minute, and more than 99% of the conflicts were eliminated just by doing it more frequently. So with merge replication, you want to make sure that you're synchronizing it often if you have lots of changes going on at different locations. The other thing to keep in mind with merge replication, I mentioned that there are changes to the tables. There's usually a row GUID that's put in there or a unique identifier to identify every row. But merge replication also works by putting triggers on the tables. Generally, you have triggers that are going to catch, I think there's 2 or 3 triggers that get put there to be able to catch any type of changes and then track those changes, and that's how it knows, that's how SQL Server and replication knows what has to be sent back from each of those publishers back to the subscriber, or what needs to be sent from the subscriber out to the, I said that backwards. That's how SQL Server knows what's going to be sent from all of the subscribers back to the publisher or from the publisher out to the subscriber, is that it has a bunch of triggers on all of the tables that are being replicated so it can know when things are changing and what needs to be distributed, updated, or sent back and forth. Each one of those 3 replication types, whether it's snapshot, transactional, or merge replication, they all have specific use cases, and it's best that if you're going to use replication that you understand them all so you can make the right decisions as to which one is best for your environment.